All right. On the last video that I made for 8.5, we had found the equation for number 35, a line that passes through negative 1, 3, and is parallel to 3x minus y is 4. So we'd gone that far, and we have an equation. But one thing the directions said was to put it in standard form. So we kind of need to review what we need to do for standard form. In standard form, a line equation looks like ax plus by equals c. What's that trying to tell you? It's telling you three things. Put the x and y on one side together, c on the other. The constant is what c stands for. The ax and by, that's just the x and the y term. C on the other, okay? The next thing it's trying to tell you is that, well, and it doesn't really tell you this outright. You have to read some things in the book and know this. But mathematical convention says that A is positive. You don't want to start an equation with a negative number. It freaks people out. And it's kind of like just polite communication, but that's what they define standard form as. You've got to have a positive x term. So if you have a negative x term, you can either move things from side to side by adding, or you could multiply every term by a negative 1 or divide a negative 1 out of every term, and that would change all the signs on each term. And you could get a positive x that way if you have a negative 1. The other thing is no fractions. People do not like to look at fractions, so what we do when we put something in standard form is they kind of clear it out and make it nice and pretty looking so people won't be so intimidated by it. Because honestly, people would rather have whole numbers than fractions. It's just the way we are. Okay, so let's put this one in standard form. It's not going to be too hard to do. If I wanted to, there's two ways I could do this. I notice that I'm going to have to move some stuff around anyway, right? Well, I have a 3x here, and it's already positive. So let me do this. Let me move the 6 to the other side and keep the 3x where it is. And let's see, I got to get the y on the same side as the 3x. So my next step, what I'll do is I'll move the y to the other side by subtracting it. I don't have to do it this way, but this is one way I could do it without having to multiply through by anything, which a lot of people just don't want to have to do that, and it's okay. You can if you want, though. I kind of explained that a minute ago. So I have negative 6, because this cancels out, is equal to 3x minus y. And also, when we put it in standard form, we're trying to, if you notice, they have the ax plus by on the left-hand side. So I'm just going to switch the two sides and write it this way. If they're equal, it doesn't matter if I put them on the left or the right, correct? That would be standard form. So that's what they want you to do on 35. I just didn't have time to finish it. Now we're going to go on to 37. We did not do this one in class. We ran out of time, so I'm going to do that. The line that passes through negative 4, negative 5, and has the same y-intercept as x plus 3y plus 9 equals 0. So we want the y-intercept from this, which is weird. Normally this is not the kind of thing you would do with the problem, but for some reason you might want to do it. All right, so this is a point on my line. I know that's an x and that's a y. If I'm going to write an equation of a line, the easiest one to kind of use to write the equation that there is an easier one, but I don't want to give you that to you too soon, but I will eventually if the book doesn't. Okay, so I've got y equal mx plus b, and I'll know that since I have an x and a y, I've seen in a lot of problems I could go plug those in here, couldn't I? Now, usually when they give me another equation, they want the slope of the equation, but that's not what they want here. They want the y-intercept. So I'm going to come over here and work a little bit on this piece of it here. If I want the y-intercept, I could still put it in y equal mx plus b form, because if you remember, the b is the y-intercept. So that's what I'm going to try to get off here, is the b of this equation. On this equation, I only care about the b because that's what they wanted. They told me get the y, basically they're telling me get the y-intercept of that one, but ignore everything else. This line, when I solve for y, I won't have my equation that I want, but I'll be able to find the y-intercept, and then I can go put that in on the equation I'm writing over here. Because if you think about it, on the equation I'm writing over here, I've got a y value I can plug in. I've got an x value I can plug in. I don't know the slope, so in this equation I'm going to be solving for the slope. And then I'll be able to fill in this plus b part once I get this right hand part over here. Once I take x plus 3y plus 9 equals 0 and solve it for y. So if I want to get y by itself, I can move terms to the other side by adding or subtracting them. I don't want to divide anything here yet. I always divide stuff last. But first, I want to get stuff on the side I want it on by adding or subtracting. So since I want y by itself, I'm going to move the x term over the other side. And if I want to, in one step, I can go ahead and say, oh yeah, I'm also going to move that 9 over there. Kind of hard to get it fit on here. So this would cancel out, and this would cancel out, and I would have 3y. If you want to do that in 2 separate steps, you can, but it's also okay to do 2 things in a step. If, you know, it's like this, it's just nice to not have to write it down twice, right? So I have negative x minus 9. Remember, I only want the y-intercept. That's going to be my b. If I remember, that's what b is, right? Okay, so I've almost got y by itself. What do I need to do to get it by itself? Now's the time. I got to split the 3 and the y apart because I got to get rid of the 3. They're joined by multiplication, so what's the opposite of multiplying? Dividing. So I'm going to divide the 3 out. I always divide last. So if you need to kind of memorize that, you can say divide last, and repeat it as many times as you want till you kind of get it in your head, at least on these type of equations. So now I have y equal negative x over 3, minus 3. And all I care about is the y-intercept. And if you remember, this is y equal mx plus b form. So I care about this time instead of the slope. Most of the time you care about the slope, but they're just being weird in this book, okay? Which is good. It's very rigorous. Okay, so if b is negative 3, that's my b that I'm going to put right over here also. So I went and I put it in over on the left-hand side because I can't write my equation until I have the slope and the y-intercept, right? And so I've got everything else but the slope. So if I look, I can plug it into y equal mx plus b. And since I only have the m missing, I'm going to solve for m now. All right, so let's do that. If I want to get m by itself, I divide last. So I am not going to mess by that negative 4. By the way, if that negative 4 is bugging you like that, write it this way so it looks normal. Okay, if I want to get m by itself, the first thing I'm going to do is add or subtract because I'm going to divide last. So I'm going to add 3 to both sides. It's a plus. And I've got negative 5 plus 3 is negative 2 equal negative 4m, and that these cancel out, right? To get m by itself now, those 2 things are smushed together. So remember, it's multiplied together. I'm at that part where I'm going to divide last, okay? Because I've got multiplication here. When they smush them, that's just multiplication. So to get m by itself, I'll divide each side by negative 4. Oh, that negative over negative is a positive, and 2 over 4 reduces to 1/2. So my slope is 1/2. So I have a slope of 1/2. And okay, so let me encircle in yellow the important parts. Here's my slope. Here's my y-intercept. I got it over here, right, from this red circle. So I have a slope of 1/2 and a y-intercept of negative here. So a slope of 1/2 and a y-intercept, which is my b. That's what b is. They didn't want to write y-intercept out. Too many words. Negative 3. So if I want to write y equal mx plus b now, I got what I need, don't I? I have a slope of 1/2, and I have a y-intercept of, it's a minus 3 or a negative 3, so I'm going to turn that into minus 3 just to make sure I show the sign on it. Now that is the equation in slope-intercept form. Just going to abbreviate here. But the directions said they wanted it in standard form, and we just went over standard form at the beginning of the video, so look back at those notes if you need to. All right, So that means that I want it in ax plus by form. I want to put the x plus by is c. Put the x and the y on the same side, and remember, a has to be positive, and no fractions. So here we go. This time I'm going to do it, I'm going to move and have a negative x just so that maybe you won't be afraid of them, okay? I got a y over there. If you don't want the negative x, remember, you could leave the x where it is, subtract the y from both sides, and then add 3 to both sides, and you would have a positive x. I'm just going to do something a little different here, just to show you that it's not really anything to be afraid of if you have a negative. Okay, so if I have y equal 1/2 x minus 3, I could say, oh, my y is over there by itself, and I just want to subtract the x and get it over there. So now I have negative 1/2 x. That cancels out. I got a positive y, so I'll put a plus y, and that's equal to negative 3. So I've done the first thing. The x and the y are on the same side, and the constant's on the other. So now what can I do? First of all, I don't want a negative x, so let's just take care of that first. I'm going to multiply everything by a negative 1 or divide everything by negative 1. Most people prefer to divide. I prefer to multiply because I don't know, division just kind of freaks me out sometimes when I'm looking at it if it gets too complicated looking. So everything gets multiplied by negative 1. Okay, so I'm going to make a bracket over on this side and put the negative 1 out front to multiply. And I don't have space to do that, so you're just going to have to bear with me. Pretend that negative 1 is out in front of that bracket. And then I have to multiply the other side by negative 1 because everything has to be multiplied or divided by the same thing. If I do that, that just changes the sign on everything. Notice the answer is going to be 1/2 x minus y equal positive 3, but let's go through and let me prove it to you. You can just change every single sign on every term in the equation like I just did, and that's going to be your answer once you multiply by a negative. Let's prove it. A negative 1 times a negative 1/2 x, negative times negative is a positive 1/2 x. That's what I wrote over there. A positive y times a negative 1, a negative times a positive is a negative, so I would have a negative y, and that's what I wrote over here, isn't it? And then a negative 3 times a negative 1 is a positive 3, and that's what I wrote there. So if you want to, if you kind of are convinced of that, after you do it enough times, you become convinced of it, I could take and just do what I did in the first place and I changed every single sign on every single term. I'm almost done. What I need to do now, though, is to get rid of the fraction. So I'm going to get rid of the fraction. I'll use this color. Okay. So if I want to get through the fraction, I'm going to multiply through everything by something that will clear the fraction, and I don't want to make it huge. I want the smallest thing I can think of. Well, there's only a 2 in the bottom of the fraction here, and we only got one fraction. So I'm going to multiply by 2 on both sides, and that means every single term, not just the first term. Remember, when I do this, I got to distribute that 2 on the left side. So 2 times a half x is just a 1x, and I'm just going to write x because that's what we would do. 2 times negative y is negative 2y. And 2 times 3 is 6. Ta-da! We're done. Okay? So the biggest mistakes people make, they freak out when they get a negative. Okay? You can always just get by that by changing all the signs. The other mistake I see people make is they forget to multiply every term when they're clearing a fraction. Okay, yeah, y didn't have a fraction, but that doesn't matter. You just can't go in and pull out a random term and multiply it by something. Your equation would not be balanced anymore because you changed something. If I'm going to keep it balanced, every single term has to get multiplied by the negative over on the left-hand side when we were doing it, and then by the 2 over here when I was clearing the fraction out. Now I have my equation in standard form, and I'm done.